All right, it's time. How's everyone doing today? Is everyone ready? See, we got some people joining us on YouTube. This is it, guys. Today, we are going to be doing our last lesson of AI Agent Camp, and we are going to be making a computer use agent. So, first of all, how's everyone doing today? Has anyone used a computer use agent before? What kind of stuff have you seen recently? Hey Raj, saw your stuff on LinkedIn and Twitter. Great work. Um, has anyone? Oh, Harsh, great. Good to see you. Can't wait to see what you guys are gonna build for this. Um, what do you guys think about computer use agents? What have you seen so far? Has anyone seen? Has anyone seen? Of course, the big announcement yesterday was OpenAI released their operator, and that combines a lot of the stuff that we just did in the last lesson. So for anyone who's watching this, yeah, operator, harsh. So for anyone who's watching this, today we're going to be making a a fully automated computer use AI agent that can control a computer. Who knows if we're going to be able to do it in an hour? I think we have a good shot at it. But if it's your first time watching, I really recommend you go back and you watch the earlier lessons that we've done. We did how to make a React-based agent, how to make a JSON-based agent. We did after that code execution agents and browser use agent. And I know a lot of you here joined us for the browser use agent, and that's going to be super useful for what we're going to do today. Hey, good morning. I think that's Brian. And so yeah, we're going to get started. Also, one other thing I wanted to say was at the end of this lesson, if I forget, remind me. I want to talk about what are the next steps for you all after completing this course. So yeah, let's get started. Let me just talk a little bit about my work with computer use agents real quick. So this is a project that I've been working on actually for a little while, and I'll send a link to this blog post for everyone. This goes way into the details about what I've been working on for the past month, or actually even longer. But essentially, the goal was to make an entirely open source agent. And as you can see here, it is a Ubuntu system, but it would work on any operating system. And the AI is controlling the mouse and the keyboard of the operating system. And as someone just wrote in the chat, like, would this work on a mobile operating system? Yeah, this system would actually even work on a mobile device, and I even have a friend who's using nearly the same thing that I have, and he's using it to automate iPhones or Androids, and it's really interesting. Now you have to try it to see how good it really is. Today we're just going to be going through how you can make basically what I've worked on for a month in an hour. So it's going to be really rough, and even the ones that are even the really good computer use agents, they still struggle constantly to get things right. But it's an area where things are moving really fast. So I think this is going to be super relevant for anyone who's interested in building agents right now. All right, so let's just get started coding right away, because this is going to take us the whole hour that we have left. So who here remembers E2B, and who here has a Grok API key set up? Those are the main things that we're going to be using today for this. If you have E2B and Grok, then you're pretty much good to go. Perfect, Burhan. So we're gonna do what we did before. We're going to pip install E2B code interpreter, and this is just going to give us access to the cloud server where we can host the remote execution environment. And that's important. I'm not going to be running any LLM generated code on my own computer or even allowing an LLM to click my mouse. For a variety of reasons, I don't really think this is a good idea as a developer to be testing this way. Most of all, that it's insecure, it's not safe. Anything could happen. So moving on, once I have that installed, this is the same code. I'm gonna just copy the same code that we used in the code execution lesson. So we're importing the E2B code interpreter, and but let me delete that because oh yeah, sure, and I'll share this with you all. Link, copy link, of course, so you all can follow along as we are building here. Perfect. Great. So this is the exact same code that we had before to create a new cloud sandbox, right? And we're going to change one thing here, which is I'm going to just add template equals desktop. That's all. And that's you're going to see in a second what features that enables, but it enables the core feature that we need today. Let me run this, which is that you can have a desktop operating system. In our case, it's going to be Ubuntu, because that's the easiest one to, it's open source and it's really easy to spin up. Okay, so now, let me name this computer use agent. So now, let's see the desktop. All right. So so we had this command. I'm not sure if I showed it before, but we were running Python commands. But I think I mentioned you could also run shell commands. So this is just like Unix shell stuff. But there's a command called scrot, which takes a screenshot of your desktop, and I'm going to be basically taking a screenshot to prove to you all that we actually have a real computer here. So let's save, and then the argument here is just the screenshot path. And that saves the screenshot on the remote computer. We need to have it on the local setups that we can actually read it. So to do that, I'm going to do sandbox files read screenshot path, and format equals bytes. So it comes back as bytes. Then what I can do is I can use the exact same code that we had before for not the code execution agent, but I can use the code that we used 2 days ago for the browser use agent to show that image here in the notebook. Just the same way that we were taking a screenshot with Playwright, I'm going to now display that here. And all this code does is it's just scaling down and then showing the image here in the notebook. Cool. So there it is. I hope you believe me now. This is a real desktop operating system that we have here running in the cloud, and that's why we use E2B for this. It just takes a minute to get it set up. And yeah, let's see that this is actually a real computer that you can do stuff with, and it's not just an image. So everything we do, we have to do with code. So I'm going to run another command, and this is a shell command. Now, how would you move your mouse if you don't actually have access, if it's not a real machine and we don't have access to a real mouse or the USB of the computer, it's a cloud, it's a cloud environment. How would we do that? Well, there's actually a command, a shell command that you can use for that, and it's called x. Oh, let me open it right here. It's called xdoTool. All right. So check out this really cool tool. We see the GitHub page here. Fake keyboard mouse input, window management, and more. It's a really awesome tool. You can have it on Ubuntu. You can even run it on Mac OS. So I could run this on my own laptop. And this is how it works. So here I will run xdoTool mouse move. Let's say let's just put in some coordinates, 500, 500. And then once that's finished, I'll run this screenshot code again. Did it move? Did anyone see if it moved? Let me run it. Let me put it somewhere else. I think that might have been where it was stuck. Let's see. Let's see what if I add in sync there. Maybe it needs to. The sync means that it's supposed to wait until it's finished moving, I believe. So now we're waiting. Let's see. Running. Okay, this is not what normally happens. So let's give it another second, and if that doesn't work, okay, I stopped that one. It seemed to be, okay. So it looks like maybe the sandbox might have timed out while I was talking for so long. So I create a new sandbox, just run all the code again. That does happen if you talk for a long time. If I talk for a long time, let's see. Okay, so I have xdoTool, mouse move, sync, and here, possibly the screenshot needs to be deleted before I can create it again. Let's see if that's the issue. svx.files.remove screenshot path. Let's see if that makes any difference. I swear I tested all this before. There it is. Okay. So I'm not sure. I really don't know what happened there. But so here the mouse is moved. And let's run it again. Let's move the mouse somewhere else. See, now it's at 200, 200. Possibly, I think I might have just skipped this, removing the screenshot path. And maybe that, yeah, maybe because I didn't remove the old screenshot from the system, it wasn't the screenshot command wasn't able to save the file. That's really interesting. I never never encountered that yet. So let's move on. So now we're able to move this mouse. Let's click on something. So I know this is a scale image here. So if I would just kind of measure, I can measure here where something is. So this is 260, 374. Okay, so let's see, with height. So that should be about 500 across, and then I think that this comes up from the bottom. the dimensions actually come up from the bottom with, no, that's right. So here it's 500 across and then 370 down. If I multiply that by 2, because we're at a scale of 2, I get to about 750 down or something like that. So let's try it. 550, 750. So now the mouse is here over the dock, okay? And so let's try and run, let's try and click on something. Let's see, how much time do we have left to make this agent? We have 45 minutes left. I think we can do it. Commands.run. And to click on something is the same, X do tool, click, 1. 1 here means the left mouse button, so I could do the right. I could do 3 for the right mouse button, 2 for the middle button. Let's run this again. Okay, now something has changed, but we don't see the web browser yet. Not everything happens right away. Cool. So there's the web browser, and yeah, we can keep doing things like this. So if I wanted to click on the address bar, I could click on that. I could use X2 tool to type, and then I could even use it to hit the return key. You can even use it for, I think you can even use it for dragging. So all sorts of, basically everything that we need to do with the computer use agent, we can do via this command line command. And even without this one, there are some other tools you could use, but this one has worked really well for me so far. So that's just the environment that we're going to automate. So this is just getting set up. Now, what we really want to do today is we want to make an agent that completely controls what's going on in the computer. So not just needs to be able to move the mouse, but it also has to be able to see what's happening. It needs to be able to get context from that computer. So before we do anything else, let's make a flowchart diagram. These are all from the past lessons, right? Let's make a diagram. Find some space. And yeah, let's think about how this is going to work. So we have an LLM, right? That's for sure. That's the core of it all. And we are going to the user is going to make a prompt. It's going to prompt the agent to do something, you know. And that is going to go into the LLM. And after that, just like we had before, we're going to have to make a decision, right? What should we do next? Okay. And there's two options, basically. One is finished. So one is if we're finished. And then the other is using a tool, right? And that's going to be based off of the output of whatever the LLM says. So the tools that I've integrated into my own computer use agent that I made, if we look here, I don't know if you can see that. Let's see. Essentially, here what I have is I have clicking, typing, pressing keys, shell commands. You can even you can even add file reading, file writing as specific tools. Today, for the time that we have, I just want to focus on the main tool that I want to focus on is clicking, because what we did before in the last lesson, if I can remember, we didn't show how to click, but clicking really is the main challenge of something like this. Typing is pretty straightforward, but yeah, clicking is a lot more interesting. So we're gonna do that one, and then we'll briefly see how you can do other things like typing and writing files. So let's throw in the click one here. Click mouse, and then also let's say type text, because we know we're going to need that for sure as well. We won't be able to do much without that. So this is one tool that we have, and this is another tool that we have. And this is going to be all based off the output of the LM. And then once that's finished, we're going to go back here to see if there are more steps remaining to be done. Okay. One thing that I'm missing still is I need to, the LM needs to be able to see what's happening, right? So here we are giving the prompt to the LM, and just like we did in the browser use agent, wait, we didn't do this in the browser use agent. In the browser use agent, we passed a list of elements that were on the screen, right? And so we looked at what was on the page, and then we summarized that for the LM. Well, one thing we could have done that I discuss at the end is we could have actually added in a screenshot. And for today, that's going to be super necessary because there's no great way, especially on Ubuntu, to summarize the contents of a computer screen just as text. You really need to be able to see it with the colors and the UI elements. What's a text box? What's not a text box? That needs computer vision. Someone had asked, can it escape the VM now? No. We are betting on the fact that it cannot escape the VM, and that's critical for the safety of this, and that's something that you need to have security experts to test. Fortunately, E2B is pretty safe like that. So let's, as far as I know, so let's go on to implementing this in the code. As I kind of referred to before, clicking the mouse is a bit of a challenge. Also, we haven't seen yet how to pass images to an LLM. I mentioned last lesson that you can do that, and you all have probably done it before via the web. Maybe on ChatGPT, you've dragged an image in and you've seen that it can read it. So let's see how you would actually do that in code. And we have this screenshot here, right? So the screenshot is stored into this image variable here. So let's just do that. So I'm gonna go to the OpenAI tool use example that we just keep referring to, and we're gonna be using this whole example again. So this is a function calling example, and I'm going to change the. We're not going to be using GPT. We're going to be using today Llama again, and I'm going to change it to use Grok. Now Grok with a Q, not Grok with a K, which is Elon's thing. Grok with a Q is just a host that provides you access to Llama. And the reason why I'm using this today is basically just the combination of vision features. It's the vision support with tool use works on Grok, whereas the other ones are not. It's not working properly. So yeah, so I've changed the client to now be using Grok. I'm gonna have to change the model here, and we want to make that. Let's go to Grok and find it, the model that we need. So I can go to here. It's under products. I'll just search for Grok models here. All right, so we need vision. And there's not too many models that support, there's not too many open source models that support vision. And looks like this is exactly the one we need. Llama 3.2, 9dB vision. So I'm gonna copy this and I'll paste that here, replace the GPT-4o with that. And let's forget about the tools for now. We'll add them back in. And we need to figure out how to add in, how to embed the screenshot that we took into our request to the LLM. That's going to be a key step, right? So basically, the way that we do that is, if you think about the way that the messages to the LLM are structured, it's basically like your chat history in ChatGPT. So here you have like a message, you have a message from the user, then you have a message from the assistant, and then you have a message from the user and a message from the assistant. Now within each message, you can actually have a combination of images and text, right? So this content here, what is the weather like in Paris today? I could say something like, how many cats are in this photo, for example. Now, in order to make that work, basically what you do is you turn this into a list, okay? And in that list, you can have various things, which are objects. So for the text part of that, I'm going to say type text, and then text is the text. So this looks very verbose the way that it is here. Let's run it and see that I haven't made any mistakes. Let's see, it works. Okay, I'm a large language model. I don't have real-time access to weather conditions. That makes sense because we commented out the tools. So here's just text, but the magic comes when I copy this and then I change it from text to image URL. And you're probably thinking we don't have a URL for this image. What we're going to do is we're going to create what's called a base64 inline URL, a data URL. And the way that works is we're taking this screenshot that we have, we're going to use the base64 library, and we're going to use that 64.b64 encode. We're going to encode the screenshot and then convert that into UTF-8, which is text encoding. So basically, we're converting the data, the bytes that we collected before from the screenshot, and converting that into a string representation. It's the same data, but it's going to be something that looks as text without all of the weird question mark characters when we print it out. Now, it's not going to actually show anything that we can see, but if we would then reverse this and decode it, we would get all of those bytes back, and we could convert that into an image file, right? Because normally in an image file, you would have a lot of data that would not be able to be encoded as text. So let's take this here, and we're gonna have to put this string into here somehow. And the format by which they do that, it looks like this. So we have image URL, and don't ask me why it's like this. URL, this, and then you have data image slash. I don't know why I've done it as JPEG so far. Maybe it would work as PNG. I'm not totally sure about that. And then add screenshot Now this is, I know this is like a weird thing that you're seeing right now. You're like, what's going on? Someone came up to me at a hackathon the other day and asked me how you do this. And I showed them how to do this, and it's like, here's the secret of how you put images in. But it comes from the web protocols, basically. So let's see. That should work. So we're taking the screenshot, converting it into a string, into this data URL specification. Let's do it as an F string, like this. Oh, and this should be equals. Yeah, and that should work. So I'll just say what's in this image. All right. Let's see. Yeah, Dima, you're totally right. You have to be really certain that the code you're running is properly isolated. And I will get back to that in just a sec, once I fix this error. Okay, so we got invalid image data. So basically, let's see, this is data image / JPEG base 64. Okay, looks correct. Yeah, looks pretty good to me. Let's see, maybe I've done something different. Let's see if this is right. Okay, this does look fine. Invalid image. I've never got that one before. So we're using Llama Vision Preview, which I've done this last night. I know that it works. I have data image / JPEG base 64, comma, there. This one it's probably a small mistake somewhere that I made. Base 16. No, it's definitely base 64. This is definitely right. So yeah, I've just done this, so we should see if there's the invalid image data. That's strange. Let's just test it real quick. Base 64 image encoder. So we can do this manually, right? So I can drag and drop images anywhere. I just need an image, right? I don't know if this will work. Oh, cool. Let me check that. Let's see. So I copied this, and what if I put this in here? I'm still getting an error here. Let's see what Raj gave. Okay, here. Did I write base 16? Oh, this. I'm sorry, Raj. I thought you were saying that I needed to change it to base 16, but I had converted it into base 16 instead of base 64. Oh my gosh. Thanks, guys. All right, good. We have all of this team debugging. Thank you so much, Raj. I should keep a close eye on the comments. Ah, okay, there it is. Okay. I blame the autocomplete for that. Thank you, team, for sticking together for that one. So, what do we get back for the from the image. Sorry, from the LM. This image shows the Firefox homepage. There's a line drawing on the left of two people hugging the world. Both figures appear to have dark hair and are wearing black shoes, black pants, and a white. And I was like, what's going on? Actually, very close. So it's very close to actually what's happening in this image. It thinks there's two people, which is cute. The world is surrounded by a flame, has the words "no trouble." Okay, now it is hallucinating a bit. Under the illustration is the Firefox logo, and then it goes on to say more things that are real on the page. All of the buttons that are on the page. Well, this is super detailed. You have a button that says browse the web. So basically, yeah, Burhan wants to know if we can play around with temperature. Yeah, you can play around with it, but this is actually the default setting is normally like that for a reason. So it should be, uh, it's definitely gonna be not one of the first things that you're going to adjust when you're experimenting with your agent. But it might be something at the very end to play around with. So what are we seeing here? We're seeing that Llama, in particular, we're testing with, remember, Llama 3.2. Llama 3.2 does work with vision or multimodal input, and it roughly gets a pretty good idea of what's happening on the page. It doesn't read it perfectly, and in my interpretation, like it made some small mistakes. Like it hallucinated some text. Um, what what was it saying? Trust no one or something. Um, I have to go back to the recording for what it said, and then it was saying that there's two people here, but for the most part, it gets all of this stuff that's going on, and basically, um, this is really useful for what we're trying to do today. So we figured this out, how to pass the prompt and the screenshot into the LLM. We figured out how to click, right? And typing text will be really similar. So what we need to do now, we didn't really figure out how to click, did we? Okay, this is another huge challenge that I had when I'm able to. This is another huge challenge that I had when I was first building Computer Use Agent. Someone said they were getting, just now in the chat, that they were getting censored by the LLM. Yeah, I had this too. I had a lot of times that you'd pass an image and it would say, I'm not going to engage in this discussion. Change the prompt that you give, change the text prompt that you're giving here. And this has for some reason, this has a drastic effect on whether it gets censored or not. So now, imagine that we want to actually click on something, right? Like imagine I'd say here, I want to see pictures of cats. What should I click on? Okay. Let's see if this works. There appears to be no cats in the image. You should try clicking on, web browser, browse the web options, okay? You could always type pictures of cats into the address bar. That's what it says there. So what if I would want to actually move the mouse there? So there's a lot of computer vision models which are really good at identifying text. So we could use one of those, right? And we could use that to find, maybe find here where it says search or enter address. We could click on maybe this stuff on the top of the page. Um, but nice prompt, Harsh. Uh, you should definitely try that for your project. So, but those basic OCR, optical character recognition, um, models, they're not going to do very well for like UI elements. Especially in my experience, they had a lot of trouble telling what's a text box and what's not a text box. um, that's hilarious, Burhan. Um, so, so basically, um, so what we need to do is we need to have a much more sophisticated model. So, Burhan, I think that's just the exchange rate that you have over there. Burhan said, where they're talking about prompting the model using monetary rewards. So, some are offering the model $1,000, some are offering $10. That's that kind of prompt engineering techniques is way too advanced for this class, so I'm not qualified to teach that. But yeah, Jordan says that the his mouse is not moving. I had that for a while, and it was just the screenshot wasn't getting updated, so I had to add this. I'm not sure what it is. Try starting the sandbox again. What I was getting to, as we are rapidly running out of time here, is that we need to be able to move the mouse and to be able to click on things. And I've gone through all of this in quite detail in my blog post here, in the section of. So we have some different sections here. Let's go to the table of contents. Security. These are the main challenges: security, clicking on things, reasoning, um, finding an agent framework, or not using an agent framework, um, which is the option that we ended up going for. Deploying LLMs and streaming the display. So let's talk about clicking on things, and you can see more in this article about my thought process. But today I'm just going to give you the solution, and the solution for this was really interesting. Um, I thought this was going to be really difficult, and then I came across a new series of models which are fine-tuned to output spatial information. And this is a type of LLM. So if we go to something called OS World, you should just be able to search for OS World. You find this really interesting benchmark. Now this is not like a general problem-solving benchmark for LLMs. It does a little bit of that, but what it's mainly for is seeing if an LLM can identify like a button on the screen and figure out where it is, and that's exactly what we're trying to do. And they have these crazy examples, but what I ended up doing was integrating. I've never seen it work that well in real life, but I think that. No, I should correct myself. I've never seen the agent work that well in real life, but the model that can actually identify where things are on the screen, it works really well. So at let's just look at the final benchmarks that they have here. Um, it's somewhere on this page if you scroll down. So there's a few different benchmarks here. Sorry, a few different models that have been ranked. Like we see here, Claude. Claude does really well at identifying items on a screen. And then there's a bunch of these that are really new, that either I haven't tried or I could not find the weights on Hugging Face. This just shows how fast things are moving, because look where all these are from. These are all from this month. Um, except for Claude, which was the computer use was released in October, and they haven't updated it since then. So the one that I'm using that actually works quite well, which was, it was close to the top a couple months ago, is OS Atlas base 7B. So we can check out OS Atlas on Hugging Face. Here it is. There's a lot of stuff on the Hugging Face main page when you get there. But if you check this out here under Spaces, you actually find an interactive version of it, which just shows you right away what it does. So let's click on one of these example images, and we can prompt anything here. So what should we look for? Jonathan, what's like a good test for something like this? Basically, we want to just ask it to find something on the page, right? Like search box, for example. And if I click, so we're prompting the LLM with this image plus the prompt search box. And this is what you get back, which you cannot see. Let me open it in a new tab here. You still cannot see. Let's see. How do I get this image where you all can see it? Let me. That's rather awkward. Let's see. I can. It's on the wrong side of the screen. So basically, here I can put it, maybe I can hide myself for a second. Would that work? No, it's risky. I don't want to mess with the. So basically what it did is it put a red box. Here I can copy the image and then put it in a new document. So everyone can see here. Let's see here and there. Okay. Now you can see here, it's put a red box right around the text box. Isn't that awesome? Like we said here, so all we said was search box, and just based off that information, it put a red box here. So let's do one more. Of course, like if you do something like discussion, it should be able to get that one right away. But yeah, as we're running close on time, yeah, let's just yeah. So there's an example for the discussion. Let's throw that in. Let me show you how that works, how that looks. Oops. Let's see. Copy image here. Here, so you can see now that the discussion item is in this box. This is really amazing, and I really recommend that you go to the OS Atlas website, check out this paper, and they have described in detail how they fine-tuned an LLM to output those four, well, it's really two sets of coordinates that define the box that you're looking for. Really cool. So that solves this problem perfectly. So the way that I'm going to implement that is that when the LLM wants to click on something, this is the way I decided to architect it, and it worked quite well for me, is when the LLM wants to click on something, it doesn't output the coordinate, but it outputs just a description of what it wants to click on. And then we have a secondary LLM right here, right? That converts query to coordinates, right? And so this secondary LLM is OS Atlas. So that smaller LM, which is 9B parameters, that gets called only when the reasoning LM decides to use it. Jordan, if you're having trouble with the screenshot, I'm sorry. Send me your notebook, and I'll have a look and make sure that it works. Or maybe you can post it here in the chat, and someone else can find what the issue is. So I want to just give you all the solution directly for this, because this model is hosted here on Hugging Face, as I just showed you. So we're just going to call it directly using the Hugging Face API. So to do that, we're going to use, and it's using something called Gradio, which is like a Python web server. So if we install Gradio client, and then what this code does here is it's just calling that API from Hugging Face. That's all that it's doing. So if we have an image here called screenshot, we can upload that to the model on Hugging Face. That will return. So here I say click on the URL bar, and that will return the coordinates of that rectangle, which is the area that we want to click on based on whatever this prompt was, right? So let's see how we can pass in the screenshot that we have. This sandbox, as we saw before, it times out after 5 minutes, so we do need to run this again to get it to work. And here we can get the screenshot. Now I have to save this to a file, right? So that is actually as simple as doing image.save screenshot.png. That should also save it here. Perfect. To a file called image.png. And that's just because of how this code works down here. Oh, I already had that here. But basically, this is going to then upload that image that we just saved and then get the results. So let's try it. And this is a free API actually. It's rate limited. So you'll get not blocked, but you get limited if you use it a lot. But here are the results, but no API key required. And you get back these values. The query you put in, the coordinates of the box, and you even get back you even get back an image with the rectangle outlined on the original screenshot. So that's great for debugging purposes. Now, what we're interested in is getting these coordinates so that we can make a script that will click with them, right? So the way I solve that is using regular expressions. I'm doing, first I want to, this is a string here, right? And this is not a standard Python. This is not like a traditional data format here. It's just a bounding box. So the way that I'm parsing that is I'm going to use regular expression, find all, and then I'm putting in an expression for a decimal, followed by a period, followed by any number of digits, followed by a period, followed by any other number of digits. I'm passing in this item from the result. Okay. And notice that this is now actually a Python list here. So we have all of those. So let's see. And then I want to convert all of these to float number for number in. So this should convert each of these to an actual number instead of a string. Cool. Now we have 4 numbers. And I think the format for this is gonna be something like x1, y1, x2, y2. Wait, x1, y1, x2, y2, right? So what that means is that these are the coordinates for one point. These are the coordinates for another point. And that if we take whatever point, so those are 2 of the corners of the box. And if we take the point that's between these 2, we'll get something that we can click on. I hope that makes sense. I don't think I have a great, actually, yeah. So let's say this is your box, right? I think this would be one of the points, this would be the other. We're going to average the x and y values and we'll get this point, which is the safest place for us to click on. So that's just basic, that's just some basic arithmetic there. So we take numbers 0, we take the x1 plus the x2, right? 0, 1, 2. Take the average of that. And we do the same for the y1 and the y2. So then we get x average, oops, numbers. So we should get x average and y average out of that. Cool. So I believe this should be, what did we say? We said URL bar, right? And there's no URL bar here. So let's do something else. Let's see, is this sandbox still alive? No, start it again. And let's prompt for the web browser to click on that. Click on or you can even just say web browser. And this prompt just encourages it to always give a result like this. And let's get the coordinates. Oh, these coordinates look just like the ones that we used at the beginning. So I'm pretty confident that that's gonna work. So let's take this, both of these, right? Put them together, the mouse move and the click. And let's put in result X, result Y, okay, as an F string. Now let's run this. Now let's wait a second. So sorry, I went really fast there. This is the mouse move command to the X and Y that came out of the OS Atlas model. And then this is a command to click. So let's go back up to the screenshot. Let's refresh it. Cool. We didn't tell it where to click the mouse. All that we told it was to click on the web browser, and it used another model in order to do that. Cool. So we have been going super fast so far because I really want to get sort of like an agent that you all can play with. Any questions of what we have done so far? Cool. Yeah, this is totally wild, right? When I realized that this clicking problem had been solved and that was something that I could do in my agent, I got quite excited, right? Because now what's left to do is basically just to construct this loop. And yeah, thanks a lot, Harsh. And there's a lot more details on this in this article that I've sent in the chat, where I really go through a lot of problems that I was thinking about as I solved this. So we've solved the core. Yeah, it's super interesting. We've solved the core problems here of basically getting an LLM to vision, to view the contents of the screen, to view whatever's on the screen or the display. And we've also solved getting it to click on stuff from just a text description. Jordan, you got it to work. Congrats. That's sick. We're getting there. We're making a lot of progress. Yeah, OS Atlas is really awesome. The creator is on Twitter, and I've mentioned him a few times in my work here. So no doubt there will be even better models. This is called a grounding model. This one, the one that converts the query to coordinates, that are going to come out soon. Someone asked, how feasible is this on iOS without making calls to external LLMs? Oh, well, you talk about an external LLM. This one here, the OS Atlas one, is only 7 billion parameters, and what that basically means is that it's feasible to run it on device, and even so, furthermore, there's grounding models that are 2 billion parameters. I find this one works the best, but if you want to run this on device, you could use that. And then you could use, any LLM that you choose on device. So it is feasible, and it's getting more feasible every day. Can you make it work on a remote PC using TeamViewer? Sure. You could do something like that. The E2B sandboxes don't. I'm not sure if you could do it on that, but that would be super interesting to see. All right, we are running out of time. We're gonna push it a bit over today because we're so close, and we really have to make this agent work. So let's go back to the LLM call here, where we had this function, right? So as we've done in our JSON agent and in our browser use agent, we're going to define a function that can be called, we'll call it click mouse, and we'll say click on an item on the screen. Here I want not the coordinates. Llama won't do very well at that. It will do terribly. I want to say a description of what you want to click on. All right, and yeah, that's it. So let's that's mostly it. So let's undo that. Let's add those tools back into the code, and I want to let's come up with a prompt that makes sense. So I'm going to start by saying I'm going to put the image first, and then I'm going to say here are the contents of the screen. The objective is check the weather using the web browser. I put the image first because I really wanted to focus on the objective, which I put last. I'm afraid if I put the objective first, then it will get it might get more likely to be distracted by the image. That's just my thinking. So let's run this, and I think the screenshot here. Let's see. Okay, so let's print this, and then we also want to print the tool use, right? Tool calls. Let's see. Okay, we got a tool call, and this looks perfect. So the name of the action is click mouse, and the arguments are location, web browser. Location. I changed this to query for my code. That seems to make a little bit more sense. But it worked perfectly, right? So what do we need to do to finish this this loop, right? To close the agent loop so that it can basically decide what to click on it, decide again, right? Maybe click on the the web browser icon, look at the screen again, see what changed. Then maybe click on the URL bar, right? Then come back, maybe type the URL that it wants to go to. So how do we close that loop? The same way that we've done in the past 2 lessons. I will take all of this here, all right? And let's add, so we have all this that we've written so far. Let's put this into a loop. We'll give it a chat history. We're actually gonna make this empty to start. And then we're gonna have a loop. So I'll just do like while true. I need to paste a lot of code into this loop because we are getting this screenshot and we want to get this screenshot every time. I prefer to copy and paste just so you all can look back at the code and follow through as I wrote it. And so this is an enormous amount of code. Getting the screenshot, but we wrote it quite quickly, getting the screenshot, and then here asking the LM, right? And then we're getting the tools out, right? And so then what we've done before is we check, we want to check if there are any tool calls, right? So we check the tool calls, okay, running the tool. We check for them. Okay, this AI is doing a good job today. Getting the first tool call makes sense. Getting the function name from that. We've done all of this before. And then we're just going to check if the function name is equal to click element, right? Then the query, it almost got this right, but this comes out as a, as you can see above, just kind of fine detail, it comes out as a JSON string. So we need to actually import. Here we need to import JSON, and we need to JSON dot load, so we need to parse this and then get the query out of it. Same stuff we've been doing the past few lessons. I just am speeding through it right now. So if this doesn't make sense to someone who's watching, go back and watch our lesson on making a JSON based agent. So here we got that. Now we just need to rewrite this code here, right, into a function. So I'm going to copy this, and let's say move this code down here, and I can copy all of this and put this into just gonna put it into a function called def get mouse get coordinates, okay, for a query, and then I'm going to return the coordinates. So just refactoring that code into a function that we can reuse. So we have the query here, we're going to get the coordinates, and once we have that, let's say, I'll keep the naming the same, result X, result Y. Now we have those coordinates, perfect. The next thing to do is to move the mouse, those coordinates, and then to click, right? So this, and then if there's no tool calls, we want to break. We want to end the loop, end the endless loop. So what this code should do, take a screenshot of what's happening in the desktop environment, pass that screenshot to the LLM, ask it what to do next, and finally, it's going to, well, there's only one thing there's only one option that it has, right? Which is to click the mouse. And then it's going to pass the argument, pass a parameter, what it wants to click on. So let's print this query. Let's print this, and we're printing out the results of the LM. So yeah, what we haven't added yet is the history, is the LLM's, the agent's memory, or the chat history. That would be pretty simple to add in, and there's some different ways you could add it. But actually, I think for now, let's just leave that out. Cool. Let's just run it. Okay. So the sandbox has timed out. I'm gonna start that again here. And run this. Check the results. We got a screenshot. I wanted to click the web browser. Okay. Just click. Okay, so a lot of things are happening here. Let's see if let's see. Okay, so a lot is happening. The clicking is not happening. Okay, so that's what we need to see. This is not getting printed for some reason. So let's just debug that really quickly. We got the tool calls here. Okay, so we have if tool calls, get the first tool call, else break. So we know this is happening. And the function name here is click element. Is that the same one that I used in the schema above? Click mouse. Okay. So that's not the same. Okay, let's try running this again. And this is running super fast. So let's do that. So it's probably going to run a few times before. The cycle is probably going to go a few times before the web browser even opens. Let's see. So here we have click mouse. Okay, let's try running that again. Yeah, it's running really fast. So you have the icon. Okay, location. The query. I think I need to I think I didn't run this again here. It should be query, not location, right? Okay. And let me just put in a little delay after clicking. Sleep one second. Yeah, let's do this. Poor time. Let's just put in a little tiny delay so it actually can wait for something to happen after it clicks. Okay, internet browser. Okay, so it's trying to click on that. And then wait a second. Okay. Okay, the mouse is moved. Okay, let's try to click it again. All right, okay, we're seeing signs of life here. It's still trying to click, okay? Now it's clicking on something else, okay? It's still going. Now we haven't given it the ability to type yet, and so the next step here would be to go back up to these these functions that we've written, and then to add another function for typing, right? So if you have clicking and you have typing, then you have the most important ones. Then you could go and add other additional ones like running shell commands, writing to the file system, any tools that you want your agent to have. But and then of course you would also want to go in and add some memory here, so it has a little bit of context, like we've done in the past lesson. So it has a little bit of context of what it's done in the past, and add that memory to the messages so that gets added to the message each time you call the LLM. It's up to you how you want to implement that. So that's it. Someone asked, should we do something similar to await for it to take the screenshot? So with the await that I put up here, with the await that I put the sleep that I put here, yeah, I just wanted it to have a little bit of sleep after it clicked before it takes the next screenshot. Otherwise, it'll be like check while the web browser is still opening, and that's just that's just like kind of yeah, that's kind of excessive, and it will just making a ton of unnecessary LLM calls. So that is it for today. And if you've made it this far, we all got through this together. It's pretty amazing what we've been able to accomplish so far. See what we got to, right? We got to an agent that can do this, right? An agent that can do all of this just by basic Python programming with the OpenAI specification API, but using completely open source LLMs. We haven't needed to use any proprietary LLMs this whole time. We haven't needed to use any extra libraries or frameworks in order to make our agents. We've just been doing this with with pure and raw Python code. So congrats to everyone who made it this far. If you are just joining us, definitely go back and check the earlier AI Agent Camp lessons. We might end up doing this again if people are asking for it. But so far, this is it. Now, I mentioned at the beginning of this lesson that I wanted to say something about what's next. Oh yeah, Harsh is asking about the streaming, the sandbox UI. You can check my blog post for that. I've written the ffmpeg commands in there. So I just want to talk a little bit quickly about what's next for you all. So we had 4 kind of little projects so far. The projects were create a React agent in Python. The next one was create a JSON agent. The next one was create a code execution agent. And then the 4th one was to create a browser use agent. So you don't need to create something crazy. You can just be using the code that we wrote together in class and just adding a new tool or making a improvement or a modification. And then send those to me or to the forums that ideally send it to the forums that I send you by email, so that the TAs can check those for you and give you feedback. Some guys even post it on social media, which is even better. We'll just comment directly on your social media post and even repost them. Now, if you've done this and you get to the computer use agent, here's what would be awesome. What you all should do is you should check out this repository, which I made. Now I made it working for E2B, but this is I created this from the ground up, and this is my computer use agent, right? And this is here, you can just see it running. It's really similar to what we created today. This is even an old version of it, and it's improved in the past couple of weeks, especially the interface to it. Now it's got like colors and stuff here in the logs, and it has detailed logs, and it has, as you can see, it has actually streaming, right? Streaming display, like Harsh was mentioning. So my challenge to you all is to check it out. The source code is not too complicated. It's all separate into different components. The agent itself, the agent code itself, is only actually it's kind of long because we have all these tools, right? Like right click, double click, and and typing, but in total it's only around 200 something lines of code for the agent itself, the prompt, right? So my challenge to anyone who made it this far is to make a pull request and to improve something. The most basic thing you could improve would be to just integrate a new model, right? So these are the models that we have. These are the models and inference providers that we have. Add in a new model or provider that we don't have, and that's super easy. Well, it's easy if it follows the OpenAI spec. I'm fighting with the Anthropic one right now. It's completely different, but there's a whole variety of things you could probably improve about my agent that I created. And if you don't know exactly how to do it, but you have an idea, message me. It could be as simple as just adding a new model, or it could be something crazy. Who knows? Or you could add a tool like reading and writing files from the file system. The main thing is that you're actually able to test it and see whether it works better or not. Now, once you've done that, let me know. And for everyone who's made it through this course, I will personally chat with you. We can, we can have a call, and I will help you to improve your portfolio and how to take all the work from this course and to build a nice portfolio out of it. And when you've done that, I'm happy to help you introduce you to various companies in the AI agent space, particularly here in San Francisco, and maybe explore what kind of work or what kind of career might be interesting for you in this space. So that's it. Looks like we did it today. Questions, thoughts? Yeah, I'm really glad that you all enjoyed it so much. I wasn't sure when I first made it that so many people were going to engage, but I'm really happy that so many people did. And yeah, we're still here, and we're still learning together. And wow, I learned a lot from teaching this. So thanks to the TAs, thanks to Jonathan and Burhan. Yeah, I think we lost him, but he was here for the first half of this. So thanks a lot to Jonathan for helping out or helping to check the assignments, and you can find both of them on LinkedIn or Twitter. We'll send out a final email later today on how you can stay in touch with us. So yeah, if there's no other questions, then I really look forward to seeing your assignments and your PRs. And remember to message me when you've finished everything. And yeah, I'll help you out however I can. Great. All right. See you, everyone.
Bye, guys.